Hello, everyone, and welcome back to our Python Data Science Workshop series. I'm Chi, and in today's tutorial, we're going to talk about one of Python's most fundamental and flexible data structure, that is list. And before we begin, let's first get familiar with some context. So Python provides four collections of data types. They are list, tuple, sets, and dictionaries. Each has its own characteristics and use cases, and we'll get to know them in this tutorial. But for today, we're going to focus on lists, which are widely used in Python programming. And why it is important? Because lists plays a crucial role in many Python programs, particularly in data science applications. They can provide an efficient way to store, organize, and manipulate collections of data. So whether you are working, let's say, with numerical data, text data, or a combination of different data types, lists often serve as the foundation for more complex data operations. And in this tutorial, we're going to explore how to create a list and perform some basic operations on them, and use some features like indexing and slicing. By the end, we will have a good understanding of how to use lists more effectively in our Python project. So, first, what are lists? And a list in Python is an ordered collection of items, and these items can be of any type, so it's really flexible. It can be numbers, it can be strings, can be booleans, or even other lists. So let's start by creating some simple list. Here we're defining two lists. One contains numbers, as you can see they are integers, and the other contains strings. And as you can see, we define list using square brackets and with individual elements separated by commas. And if you execute this code, we just created two lists in Python, and you can also print the results. And as you can see, the list is defined. So once you have created a list, there are some built-in commands that you can use to access the basic information of the list. So the first one is the length command, which will return the length of the list. And here we're trying to access the length of string list, and we know that it only has 3 elements. And the other commands are min and max, and they are used to find the minimum and maximum value of a list. So if it's a numerical value, it will just find the minimum and maximum. But if it's a list of strings, and this will correspond to the alphabetic order of the first and last element. So the minimum elements on the string list will be carbon, because it starts with a C, and then the maximum will be water. And now I would suggest you to pause the video and try to run the length min and max command to find the minimum and maximum of the number list. Moving on, one of the most important features of list is the ability to access specific elements or ranges of elements. And this is done through indexing and slicing. So first, let's talk about indexing. And in Python, we use square brackets to access elements by their index. Here is something crucial to remember, is that Python use zero-based indexing. And this means that the first element in the list is at index 0, not 1. And as you can see, this is a bit less intuitive, but this zero-based indexing is really common in many programming languages, and it will take some time to get used to it if you're new to coding. But please remember, this is very important. So now let's try to put this into practice. And here in this example, we're trying to access the first element, of the number list. And recall that earlier we just defined this number list. And now if I execute this code, we're gonna see 4 is printed, and 4 is the first element. And if we want to print the third element, here what we need to put into this square bracket will be 2, because Python is zero indexing, and 2 is referring to the third element. And let's see if this is correct. So if now I execute this code and we see that 654 is printed, and we know this is the third element. And the other cool thing is that you can also access an element based on the position from the end of the list. And in Python, the last element of this list is indexed as -0. So if we're trying to access the last elements, we can just put -0 in the bracket. And if we print this, we can see that 4,391 was printed. And we indeed know that this is the last. And if we want to access the second last, and then we just put -2, and this will give us -12. And now it's your own time to practice, and you can pause the video and then try to find the second elements on the string list in two different ways. So you can try the forward indexing and also the backward indexing. And always remember that if you're doing the forward indexing, Python starts at 0. And now that we have some basic understanding of indexing, let's move on to slicing. So slicing allows us to access a range of values in a list. And you can do this by specify a start and an endpoint. And these will generate a new list based on the indices. And they're separated by a column. One thing to note here is that the endpoint index in slicing is exclusive, meaning that the endpoint index won't be selected. And we can see this as we can put this into an example. So here, what I'm trying to do is that first, I'm still using the same square brackets as how you do indexing, but now you're specifying the start point and also the end point separated by a column. So here, I'm trying to select from the third element. Remember that Python is 0 index based all the way to the 6, not to the 7, because the 7's because it's exclusive. So if we print this, we can see that. And another cool thing is that you can also remember that in the slicing, you can also do the negative indexing for Python list. This may be a bit too intuitive for you, but if we try to print number list square bracket 6, what this will return is actually the 7th element, and we see that this is not included in the slicing. And here, another example is that we're trying to slice from the first element to the fourth element. And what this will give us is 4, 23, 6, 54, and until 2. Exactly the first 4 elements. And sometimes you can also omit, if you're starting from the first element, you can omit this 0, and this will still give you the same result. Another cool thing is that we can also use negative indices in our slices, and this is particularly useful when we want to slice from the end to the list. So you just replace the start with the negative value that you want to select from, and in this example, we're trying to select from the 6th last element to the 2nd last element, and I've just added a -1 here because remember again, Python, when you are doing the slicing, the endpoint is exclusive. And as you can see the results, this slicing stops at -12. Let's say if you want to select backwards until the last element, what you can do is that you can just delete this -1 and just leave it empty. These will select all the way until the last element. So just a small tips. And it is also possible to specify a step size. And to do that, you just add a third parameter after the stop points, separated by a column. So a step size of 1 is the default, and this will select every element, and 2 will select every other element, and etc. And here, this code will slice from the first to the fourth at an interval of 2. So we're seeing that number 4 and 654 was selected. So we're selecting the first one and also the third one in this case. And you could also specify the steps And this will do a whole selection from the beginning all the way until the end. And this is the result we have. And here is another really cool trick is using a step of -1. And this will return the list in reverse. And in this example, this code is saying that give me all the elements from start to end and moving backwards by one step each time. And this is very effective to reverse the list if you want. And the final thing to note here is that slicing notation isn't just for list. It also works on any other sequence types in Python, including strings. And here we create a word string, and we can here again we can we can index to access the 14th element on the string, and then that will be I, probably this one, and this code will select from the beginning to the end in every 3 steps, and this will give us this string list. Now that we have covered how to access elements in a list, let's explore how we can modify lists. So lists in Python are mutable, which means that we can change their contents after they have created. And now let's look at some common operations. First, let's start by creating a color list. And in this list, initially we have red, blue, green, black, and white. So the first common operations that we can do for list is adding elements. And to do that, there are 2 main ways. The first one is the append function. So this method will just add an element to the end of the list. And in this code, I'm trying to add pink to the color list. And we can see that pink has been added at the end. The other way to do that is to use the insert function. And this method allows you to add an element at a specific position in the list. And this is specified by the first parameter in this function. In this case, it's 0, so we're adding cyan as the first element to the color list. And if we print that, we can see that cyan has indeed been added to the color list. And now I want you to also pause the video and try to practice to add purple to the list between green and black. Note that our color list has been updated, and you need to use the insert function because this can specify the location. Okay. In addition to adding elements, you can also remove elements from a list, and there are multiple ways to do it. The first common method is to use pop, and this method will remove and return an element at a specific index. If no index is specified, it will remove the last index. So here, if we do color pop, this will remove the last element, and we see that the pink that we just appended, now it has been removed. And also, again, you can specify the location. So now if we put index 2 here, this will actually remove the third element, and we can see that blue has been removed in this case. And now we only have cyan, red, green, black, and white. And the other method is to use the delete command. So here it's pretty similar to pop. So delete colors, and then you add the index to referring to which elements you want to add. And in this case, we're again removing the third element. And we can see that now green has been removed, and we only have 4 elements here. And you can also similarly following slicing syntax as before. So this will delete a range of elements from the list. And in this case, we're removing the third and the fourth elements. And now we only have cyan and red in our list. And finally, you can use the remove function. And you do this by specifying a specific value, and this will remove the first occurrence. So here we are trying to remove the red. And in the end, we only have 1 element in the list, that's cyan. And lastly, you can also sort the elements in a list either numerically or alphabetically. And here we're first creating a random list, which are made of a bunch of float points, and they're not in order, right? We can see that 0.5 is the smallest, but it's not started from the beginning. So we can do the sort function. And one thing important to know is that the sort function is an in-place operator. This means that it performs the operation on the variable directly without requiring a new variable to be assigned. So in this case, the sort function will directly modify the random list that we just created and update the list. So now we can see that the random list now is ordered in an ascending order. And again, if you set the reverse equal to true, and this will sort the list in reverse order, which will be descending. And now we see that it started from the biggest number to the smallest number. And so far, all of the list command that we have used is in-place operators. And again, this means that they perform the operations to the variable in place directly without requiring a new variable to be assigned. And by contrast, there is another type of operators which is called standard operators. They do not change the original list variable, and you must create a new variable to set to retain this operation. And an example of this will be sorted. And for now, I would suggest you to first pause and try to see if the random list was in fact sorted by using the min and max function. Okay. And sometimes we don't want the original variables to be changed. Best practice will be to create a copy, and there are multiple ways to create copies of list. But it is important to know that there is a difference between a true copy and a view. And I'm going to demonstrate in the following code. So here now we're trying to first create another string list, energy, water, and carbon. And what I'm also going to create is called a string list view, which will directly equal to the variables. And now if we perform a sort on the string list view variable, and if we try to print it, we can see that it has been reordered, right, by the alphabetic order. And now I just made this change on the view variable. And if we now check the original string list, we can see that, wow, the order has also been modified. So that's what an in-place operation will do. And the thing here is that any operation that I performed on the string list view will also affect the string list. And this is because actually they're the same list in memory. And string list view is just another name pointing to the same list object. So we're not creating any new copies of the string list. And to avoid this and create a true copy, we have several methods. The common way is to use the copy function. So you can just, here we're creating a new variable called string list underscore copy, and then we applied a copy function. But also there is another way you can use a slicing from the beginning to the end, and also you can just use a list function. You can try to uncomment this and play around with it. And now if we modify the copy we just created, right, we are sort the string list copy, and we see that indeed the copy has been reordered. If now we print the string list again, we can see that any operation that we have done on the string copy does not really affect the string list. So again, if you want to modify a list, but you don't want to change the original list, it is always a good practice to create a copy before you perform any modification. So the third operation we can do is combining lists. In addition to adding single elements to a list using append or insert, as we just talked about, we can actually also add multiple elements all at once by combining list. So here we're trying to we are defining two lists. One is rainbow and one is shade. And we can just directly using a plus operator. And these will create a new list containing all the elements from both of the list. So we have rainbow and then we have the shade in this case. And also, string can be repeated by multiplying an integer. This is also quite intuitive, right? So here we are creating two new variable string list 2 and number list 4, which are string list repeated by 2 times and number list repeated by 4 times. And if we see, we can see that indeed this is also repeating list. We can also check again the string size has been expanded from 3 to 6. So another very important thing to note is sequential list, and they are very useful tools, particularly for iterations, and which we will talk more about in the next session. But now I want to first introduce you the range function and how we can use them to create an iterable object based on the size of an integer argument. So first, let's try to see an example. So here I'm using the range function and I'm putting a parameter of 4, and let's see what this will return to me. So as you can see, you'll notice that this doesn't actually print a list, but rather a range object. And for us to construct a sequential list from the range object, we need to use the list function. So we need to add another function on top of the range function. So here we're adding a list function to wrap the range function. And see, now we have a range from 0 to 3. And remember, also in Python, ranges are exclusive of the stop value, and also it starts from 0. So that's why it's giving us from 0 to 3. And here, if we want to create a range from 1 to 10, we need to specify the range actually as from 1 to 11, and this will give us 1 to 10, like the actual range. Another cool thing, just like before when we talk about slicing, you can also specify the type, the steps. So in this case, we're creating an odd number list from 1 to 10. And let's see, this will give us 1, 3, 5, 7, 9. So this is quite intuitive. And now I want you to pause again and try to play around with a function to create a sequential list from 1 to 100. And in the end, it is worth noting that strings in Python also share many similarities with list. They are both sequences which allow us to use many of the same operations that we have learned for list in this session. So now let's look at some examples. So first, I'm defining a new variable called myString, which is equal to word. And we can use same as what we did for the list indexing to access the character in the string. So here we can access the first character, which is a W, and same we can access the second, which is an O. And similar to string, you can also subset, similar to list, you can also subset strings using an index and also access the length. Here, I'm trying to access from the second to the third elements in the string text of world, and that's OR. And also I can print the length, which is 5. It's a 5-letter word, right? As you can see, we can index, slice, and find the length of string just like we do with list. And this similarity makes string very easy to work on, especially when we are processing text data. And one powerful feature of string is the ability to split them into list. And this is particularly useful when we are working with structural data. So now let's look at an example. So imagine we have some files in a folder called my data, and in this case they're just all text file, and we want to process their name. So first I'll create this scenario. So here we have a file list which has the path to file 1, file 2, and file 3. And now let's say that we want to rename this file. So first, what I will do is that I will use a split function to split the strings based on, in this case, it will be a dot. And I'm using a for loop, which we'll introduce in the next session. But for now, you can just try to understand this like intuitively. We're using a for loop to go through all the file names in the file list, and we're trying to split them on the dot. So let's check the result. We can see that what this code just did is that it split the file structure from the base name and the extension name. And now what you can do is that you can create a new empty list, and then you run a for loop again. And then in this case, you are splitting the string again, and then you're printing the first element after the split, and then you are using this plus operation to append a new file type, in this case, which is .png. And after you have created a new file name, now you append this updated file name to the new list. And if we see that actually what this does is that it's updating the extension name for file 1, file 2, and file 3, and this append will store them into the new list. So in the end, the new list will have 3 variables, and we can see that their extension name has been updated from txt to png in this case. And I think that's all for our tutorial today. And thank you for your time and listening, and I'll see you on our next tutorial, and happy coding.